Section 1.4 is on the introduction of identities in trigonometry. So to start with that, we're going to start by reviewing some algebraic identities. The first question I want you to look at is the statement true for the square root of x squared plus 9 equals x plus 3? So take your guess if you think it's true or false and write it down. Now remember, the square root means you're finding a number that multiplied by itself equaled what was underneath the square root sign. So an example, if we took the square root of 25, we know that equals plus or minus 5. Because if we were to square either of those, it equals 25. So looking at the problem they gave us, if this is true, then that means x plus 3 squared would equal x squared plus 9. And if we were to work that out, we would end up with x squared plus 6x plus 9, which is not what is underneath that square root sign. So this is not true. So the reason I wanted to show you this is to remind you that when you are working with square roots and you're adding or subtracting underneath the radical sign, you cannot take the square root of the separate terms. The only way you could do that is if you were taking the square root of 9x squared. Now, because you're multiplying, this does simplify to plus or minus 3x. So if you're multiplying, it's okay to do that. If you're adding or subtracting, it's not. Some common algebraic identities that you hopefully are familiar with is that multiplication is the same thing as repeated addition. That's why we can write 3x instead of writing out x plus x plus x. Also, exponents are just repeated multiplication. And again, that's why we can write x to the power of 3 instead of x times x times x. And when you have a common factor in the numerator and the denominator, then you can simplify them. So the example we've got is x over 4x. Because they're being multiplied, we can simplify the x's to get 1/4. One thing I want you to be careful about is when you're simplifying fractions, if you had x plus 2x squared over x, a lot of people just want to go and simplify these x's and say that this is equal to 2x squared, which is not true. What you have to do is you have to simplify with all of the terms when you're adding or subtracting on the top and the bottom. So if we take an x away here and here, we also have to take one away there. And then the simplified answer for this would be 1 plus x. So always remember to be careful when you're adding or subtracting and simplifying, because then it usually gets mixed up, and that's where I see the most mistakes in trig. And the reason these are all called identities is because they're true for all replacements of the variable, except if it's in the denominator and it's 0. That's the only time it wouldn't work. So the next thing we're going to go over are reciprocal identities. And these you're going to want to have memorized. Some of them you probably already know. So cosecant is the same as 1 over cosine, or you can just find the reciprocal. Same for secant and cotangent. So going through some examples, we have the sine of theta equals 5 over 3. Cosecant is the reciprocal of that, so we're just going to flip it over to become 3 over 5. The signs stay the same, so we don't change it if it's positive or negative. Next, we have cosine theta equals negative square root of 3 over 2. They want us to find secant, so we're just going to find the reciprocal, and it's going to become negative 2 over the square root of 3. But if we remember, we can't have that square root sign in the denominator, so we're going to just go ahead and rationalize this, and we'll get negative 2 square roots of 3 over 3. Our next one, tangent of theta to cotangent. 2 is the same thing as 2 over 1, so the reciprocal of that would just be 1/2. Cosecant to secant. Even if you have a variable, you can write it as a fraction. A is the same thing as a over 1, so the reciprocal of that would be 1 over a. Secant of 1 to cosine is just going to be 1 over 1, which simplifies to 1. And lastly, negative 1 over 1 from cotangent to tangent would be 1 over negative 1, which is the same thing as negative 1. So it's pretty simple once you get the hang of going between the reciprocal forms. You just flip them over. Some other ratios that you're going to want to have memorized for sure are the tangent and cotangent. Tangent is sine over cosine, and cotangent is cosine over sine. And we went over the tangent one already, and because cotangent is the reciprocal, we've just got to flip the fraction over. So for example 2, they give us if sine theta equals negative 3 over 5 and cosine equals 4 over 5, they want us to find tangent and cotangent. So I'm going to start with tangent. I know tangent is equal to sine, which is negative 3 over 5, over cosine, 4 over 5. And the fraction bar is the same thing as division. So if we write this out, this is the same as saying negative 3/5 divided by 4/5. And when you're dividing with a fraction, you can change it to negative 3/5 times the reciprocal of the second one, which would be 5 over 4. At this point, you can either simplify or multiply and simplify your final answer. I like to simplify before, so because there's a 5 on the top and the bottom, I'm going to get rid of those. And this is going to become negative 3 over 4. And once you figure out what one of them is, you can figure out the reciprocal function. So cotangent is just going to be that fraction flipped over, or the reciprocal of it. So that's how you can use those identities to find a missing function. The next part of the notes is we're going to be working with exponents on our trig functions. So if we have sine squared of theta, that's the same thing as saying sine theta squared. And this indicates that we are to square the number that sine of theta is equal to. And that works for all of our functions, so we can do this for tangent, cotangent, cosine, and so forth. So our first example, they give us sine theta equals 3 over 5. They want us to find sine squared. So we know that sine theta equals 3 over 5. So to find sine squared theta, we're just going to take that, put it in parentheses, and square it. And when you're squaring a fraction, remember you square both the top and the bottom. So our final answer is going to be 9 over 25. Our next problem, they give us cosine theta equals negative 1/2, and they want us to find cosine cubed. So again, we're going to put it in parentheses, and then we are going to cube it. And when you cube it, you're going to cube both the top and the bottom. And we would get negative 1 over 8. The big thing is make sure you put the parentheses. I know it won't always affect your answer, but sometimes it does. So if you don't put those parentheses, you might forget to include that negative. And the last identities that we're going to be working with are the Pythagorean identities. Now, I know it says memorize these, but if you just memorize this first one, you would be okay. Like, this is the most important one that we are going to be using. And on a quiz or a test, that's the one that would be most useful to you to have memorized. So this is called a Pythagorean identity, and it's one that we would need to know. Cosine squared theta plus sine squared theta equals 1. And we can use that to solve problems. So if we were to use that on our next example, we know if theta equals 3 over 5 and terminates in quadrant 2, they want us to find cosine theta and tangent of theta. There's two different ways that you can solve this problem. One is using our Pythagorean identities. So to do that, if we were solving for cosine, we can start with cosine squared theta plus sine squared theta equals 1. And we already know that sine is 3 over 5. If we go ahead and plug that in, we can solve for cosine. We square the top and the bottom, and then we would want to subtract that from both sides. And we would have cosine squared theta equals 16 over 25. And next we would take the square root. And remember, when you take the square root of a fraction, you take the square root of both the numerator and the denominator. So we know cosine theta equals plus or minus 4 over 5. Then we need to look at what quadrant they told us this was in. This is in quadrant 2. So remember from yesterday, it's all students take calculus. So because we're in quadrant 2, only sign is positive, which tells us that our only answer for cosine theta is going to be a negative 4 over 5. So if you're required to use the Pythagorean identity, this is how you would use it to solve for cosine or sine. Once we have that, we can find tangent of theta because we know that is sine over cosine. So I know sine is 3/5 divided by negative 4/5. And I'm going to change that to a multiplication. So 3/5 times 5 over negative 4. I'll simplify before I multiply, and I would get 3 over negative 4, and that is what tangent of theta equals. So this is one way you could solve a problem like this. The other way, you could just use what we've already been doing, and that is drawing a picture and filling in what we know. So we know we have sine being 3/5. We can solve for that missing side, and in this example it would be 4. And then you can use that triangle to figure out what cosine is, negative 4 over 5, and what tangent is, which is 3 over negative 4. So one is a little bit more work, but if that's the way you remember on the test, that'll work. Or the second one works as well. Unless it specifies which method you have to use, you can choose any method you would like. So for our next one, they tell us that cosine equals 1/2 and terminates in quadrant 4. This one, I am just going to draw a picture because it's a little bit faster. So we know it's in quadrant 4 down here, and that cosine is 1 over 2. I'm going to go ahead and find my missing side, which would be 1 squared plus y squared equals 2 squared. And subtract the 1 from both sides. Y squared equals 4, and y would equal plus or minus 2. In this triangle, it's going to be minus 2 because it's going down. And once we have that, I'm just going to go ahead and find all 6 of my trig functions. Even though it gave us cosine, I still like to write it down just so I don't accidentally forget one. If you don't write it down, you wouldn't be docked, as long as you had the other 5 that you needed. Okay. So for this one, remember sine is opposite over hypotenuse, which would be negative 2 over 2. And wait a minute. 4 squared, 2 squared would be 4. Okay, sorry. So this would just equal -1. And then cosine we know would be 1/2. And tangent would be -2. And then for cosecant, that would be -1. Secant would be 2. And cotangent would be -1/2. Okay. So then that is how you would do this problem. Tomorrow we do have a quiz in class, and if you're going to be gone, just let me know and we will make up a time for you to complete it. And on the quiz, you will need to know the distance formula. And any of the stuff that we've went over in lessons 1.1 all the way up to 1.4. So make sure you're looking through those notes, and we will have a little bit of time at the beginning of class to go over any questions you have. And then we will use the rest of the time to work on the quiz. There won't be any extra homework after that, but that is all you'll need to do. And I'm so sorry, on this last problem, I did not solve it correctly. This was supposed to be a 3 here. Sorry, I knew it was wrong, I just couldn't figure out where my mistake was, and I apologize about that. So this should have been plus or minus the square root of 3. And then on our triangle, it would be negative square root of 3. I apologize about that. Let me just fix this really quick. So sine should have been negative square root of 3 over 2. Cosine would be 1/2. And tangent would be negative square root of 3. And cosecant, once it's rationalized, should be -2 square root of 3 over 2. Secant should be 2. And cotangent would be negative square root of 3 over 3. Sorry about that mix-up. I did not subtract when I was working through my problem. But that's everything for today, and you can let me know if you have any questions on this lesson.